All right, so we're still in P.1, but this is called solving systems of equations. And the one we're going to solve is x squared plus y squared equals 5, and x minus y equals 1. So we want to solve this system of equations, and the first thing we need to talk about is, what does it mean to solve a system of equations? What are you looking for? Okay, you're looking for x. Okay, hold on. Someone says you're looking for what? X and y, and some of you say you are what? You're looking to substitute an elimination. Now, which of those is which of those answers my question? What does it mean to solve a system? Elimination substitution is how we solve a system. How we do it. What does it mean to actually solve it? What are we looking for in an answer? And don't say find the answers. Okay, what are x and y? They're what? Intercepts? What's an intercept?
Where they cross the x and y axis?
No, we're not looking for where they cross the x and y axis. They're just variables. No, they're not.
Did you say solve a system of equations?
Yes, we're trying to decide if they know how to solve this. They know how. They know that you use substitution or elimination, but they don't know what the answer should look like. Oh, okay, very good. So we're looking for an ordered pair. So our answer is an ordered pair that describes what? A point. Any point? Because I could make up any point you want right now and I'd be done solving this.
How many solutions are there? 2. No.
I still don't know what you're telling me. What is it? What does the solution look like? All right, let's back up. What is this if you graph it? It's a circle. It's a circle. You learned that. Algebra 2, pre-calc, both places. Circle, what's the radius?
5.
It's not 5. It's a square root of 5. Where's the center of that circle? 0, 0, with a radius of radical 5, so it looks like that. What's this? A line. Okay? What's the x-intercept of that line? Make y equal 0. What is the x-intercept? 1. And the y-intercept? -1. Okay, I drew a picture of this. What is the solution to this system of equations? What do I look for on the graph?
Where they intersect.
It's where they're not lines. I have one line
Where
and
the line
one.
in the circle, the points where the line in the circle intersect.
Very good. It's the points where the line and the circle cross each other, where they meet. That's what we're looking for. So how many answers do you suppose we're going to have here? 2. To find those 2 answers, the technique or process that we can use is called substitution or elimination. Okay? That's really what math should be about, is you not just remembering eliminate, substitute. That's all you want to remember. You want to remember the bigger picture. What does it mean visually? What is my answer going to look like? That's real learning that would allow you to just, you could look at any different problem that says solve systems and work it out probably. So you need to understand the whole big picture. All right, so now let's solve this. Can we use what do we get? What's the only thing that's going to work here? Only one of them is going to work. Substitution. Why couldn't I use elimination? This one has x and y squared, and this just has, how many of you had the idea of squaring all of these? Okay? It's an idea that a lot of people have, but here's what you can't square each of these. You could square both sides, and then you'd be squaring x minus y and 1, and how would you have to square that? Foil. You'd have to foil it, and you'd end up with x squared minus 2xy plus y squared equals 1. And then you'd be using that equation and that one, and you'd have that extra weird term. That would be way more work than needed. Okay, so substitution is the method we're going to use here. We're going to take this equation and get x or y by itself. So what do you want to get by itself there? X. So x is 1 plus y plus 1, either way is correct. Now I'm going to take this, and what am I going to put in place of x? I'm going to substitute this into that one, and I'll have 1 plus y quantity squared plus y squared equals 5. Then what can I do with this? How, I know that. I need how. I need like step by step.
Well, first you should FOIL out the...
First I need to FOIL that out. FOIL here. So 1 plus y, 1 plus y. You should be able to FOIL without writing it like this and without writing 4 terms. You should be able to say the first is 1, the outer is 1 plus 1y is 2y plus y squared plus another y squared equals 5. Okay, so trying to solve this for y still. What's my next step?
Direct one over.
Nope. Add the 2y squareds and get 2y squared, and then plus 2y, and then this is a quadratic. I can't solve this by moving things from side to side. I've got to get it all on one side and set equal to 0. So minus 5 gives me negative 4 equals 0. Then I can divide everything by 2, actually. That would be a good thing to do. I could take a 2 out, but the 2 might confuse me if I leave it there. So if I divide everything by 2, I have y squared plus y minus 2 equals 0. Now what can I do? Factor. Factor. Unfoil. What two things will multiply to be negative 2 and add up to 1? Plus 2 minus 1. Then I use what's called the zero product property. The zero product property. And I'm just going to write this right here. The zero product property, this is what I had at the very bottom there. And I separate each of these, and I get 2 y values, and I'm done. Yay. Am I done? Nope, I don't have x's. My answers are ordered pairs. These are y's. So
Solve for x. Solve for y. Plug it in. The
Plug
other
in
equation.
each y for an x, so you should find its matching order.
plug in each y for an x.
No, like 2 separate equations, two different times, right?
Okay, yes. Now, didn't we already say that we should have 2 ordered pairs?
Yeah.
Are we going to have 2 ordered pairs?
Yeah.
Yeah, we have 2 y values. So these are the y values of my ordered pairs. I need the matching x values. So all I have to do is put these back into this one. One of the original 2. Okay, really one of the original 2. If I put it into one of those, who's going to choose this one to put those numbers into? Who wants to waste some more time? Okay, let's pick the easiest one. It happens to be the one you got x or y by itself in. So if y is negative 2, then x is negative 1. So they meet at negative 1 comma negative 2. Does that make sense? Is that about that point right there? And they meet when you put 1 in, you get 2, and at 2 comma 1. Hey, that looks kind of like the points from the graph. So you've got a few of those. Basically in section P1, all you have left are solving systems and symmetry questions.